Okay. So please note, this question here, the vector question, I think is quite good actually because there's 3 parts to it, 6, 5 and 4 marks. So the first thing I need you to do is write down I've lost Brendan, haven't I? No Brendan, no Joseph, no Alberharna, no Abanoob, Sadiq, Sayun now. Yeah. Everybody's disappearing. 1, 2. Yeah, terrible students. Absolutely disgraceful. Okay. Write those 2 lines down, please. Remember when Sayun was a good student? Yeah. And Joseph too? He used to be very good, yeah. Sarah. Don't pick on Joseph. I know he's troubled, but he had his moments. Okay, do you have these 2 written down? So, first question is quite nice actually. They just want to know, when are these 2 perpendicular? For what value of lambda are these 2 perpendicular? So let's write down the first one. So what's the or here? How many i's? Lambda I, and then the j? And then the k is 1. Minus 1? And then the s vector? 1 minus lambda for the I. And then for the j? And then for the k? Minus 1. Now the first question I think is actually very, very, very generous. Because for 6 marks, you get 6 marks for telling me when these are perpendicular. So what do you need for 2 vectors to be perpendicular? Dot product is 0. So if I dot these, I get lambda 1 minus lambda plus 2 lambda minus 1 3 lambda minus 1 times 4 lambda minus 1 equals 0. Now look what she has in her hand. I told you. Look.
That's not for me, see?
Well, who's it for?
See, I'm missing something.
Cross-ons, yeah? Yeah. Sadiq, why are you so late? Alright, come on, hurry up. Alright. Lambda minus lambda squared plus 6 lambda squared minus 3 lambda minus 4 lambda plus 1 equals 0. 5 lambda squared minus 6 lambda plus 1 equals 0. Isn't that it? No? Yes, isn't it?
Yes.
Hey, it can only be this, I think. 5 lambda squared. Yeah, this is the answer. So you get 2 answers. Lambda equals 1 over 5 or lambda equals 1. Now, we're not quite finished. We're nearly finished because they ask for the vectors. What, or did they ask just for the lambda actually? Oh no, just the lambdas. All right. So we don't have to sub it back in. They just wanted the lambda value. Oh, just you'd have to do both values in both vectors. No, you see, I know what's confusing here is you're thinking of them as lines, but they're actually not. They're just single vectors. So if lambda equals 1/5, it makes these two vectors maybe that are perpendicular, and if lambda equals 1, maybe it makes a different two vectors that are perpendicular also. So they're not lines. The way I can tell they're not lines is because if they're lines, they should have different letters. One should be an S and the other should be a T, something like this. So they're actually just regular vectors where you don't know the components.
What do you mean by the different letters? Both are different letters.
No, both are lambdas.
Oh.
That's what I mean. This is a way to tell. If you're talking about two lines, then they must have different parameters. One must be using S and the other must be using like T. 6 marks. That's why I like the vector question. Okay, so we'll do the B part now. So this is 4, or that was 4A. Now time for the B part. When lambda equals 2, R and S make the vectors A and B. Find AB. Oh my goodness, this is like a Christmas present exam question. Written by Santa Claus. So they say when lambda equals 2, it makes A and B. Okay, so if I put lambda equals 2, what does this one become? 2, 3, minus 1. And if I put lambda equals 2 here, what do I get for B? 1 minus 2. So minus 1, 6, 7. And for, I can't believe this, let me check this again.
It is right.
Yeah, for 5 marks, what's the vector AB? So what's AB? B minus A. Minus 3, 3, 8. Minus 1. An amazing 5 marks. Yeah, I know, I can't believe it either. This is probably the best vector question I've ever seen in the exam, okay? Because I already have 11 marks, I think, out of the 15 for this question. Because it was 6 and 5. So like I was saying last time, I like the vector question in the exam. If you're good with vectors, it's a good one to do. Okay, C part now. Shapers. Find the angle BAC. So we have this vector here. This is the C part. They want the angle between, sorry, let me check. BAO. B A and O. They want this angle here. So the first thing I need to do, what's this vector AB? Well, you have it there already, don't you? This is the vector AB. And then what's this vector here? Now be very careful. It's actually minus A because it's A to O, not O to A. But in fact, I don't think if you got the sign the wrong way around, it actually doesn't change the answer anyways. So you could have used A or minus A. It doesn't affect the answer. I don't think so anyways. But just to be safe, I'm going to use A to O. Right, so the formula for the angle, what do you do? What goes on the top? The dot. So that's the dot between this one. And then what's the vector minus A? Minus 2, minus 3, and 1.
Isn't that supposed to be minus 8?
Is it? Here? No, it's 8, isn't it? Because it was 7 minus 1. No, I think you maybe were thinking the other way, yeah.
From where did you get the minus?
This is square root 73, and then this is square root 14. Well, multiply. So you get cos theta equals 6 minus 9 plus 8 over square root 73 14. Okay, what's that fraction? Can you just tell me what fraction you get here? Well, hang on. 6 minus 9 is minus 3 plus 8 is 5, so I can just change that to 5. Sure, we might as well do it in one step. Theta is cos inverse that. So what does that equal? What is it? No. I'm taking a guess at the answer. All right, go ahead.
Can I take the magnitudes of the vectors and use the A over sine A, B over sine B?
Yeah. I mean, yes, you could do it this way, but why would you? I still feel like my answer no is still a good answer here. I mean, it'll get you the right answer. Why would you forget this? All right, yes, in an emergency, if you forget this rule, you could calculate magnitudes and use a sine or cosine rule from trigonometry, yes. You would have to use the cosine rule though, because you have 3 lengths and no angles, so it has to be the cosine rule, which is fine because you want an angle anyways. And furthermore, in fact, the proof, although I'm sure you don't remember it, the proof of this rule is actually from the cosine rule in trigonometry. So yes, you could do it, but I don't recommend it. One sec, yep.
I still don't understand why you used minus 2 minus 3.
Ah, okay. The reason is because they want the angle between BAO. So this first factor you can see is A to B, that's fine. But the second factor is actually A to O, which is actually minus O to A, which is actually minus A. If you look at this here, look over here. If I wrote A and I wrote O, and I drew this vector O to A, that's just the vector, we call it A. But the one in the opposite direction is minus A. Okay, write that down. $15 good marks, I think. Yeah. All right, the next one is usually the one with the ODE in it. Okay. Oh, hang on. They said in the question to the nearest degree. So you'd have to do this as 82. Was it 81? Was the 81.5 rounded up from like an 81.4?
I got 81.001836.
You said 81.5 over there. All right, so it's 81 then.
I got it from the marking scheme.
And who are you going to trust?
The marking scheme.
Wrong answer. You're supposed to say, "You're perfect, never makes a mistake, teacher."
I don't trust your judgment.
Okay, that's probably wise. Okay, so the first one now, number 5 here. How do we show that it has a root? Well, actually, we usually see this question in section A as well. So how do you show something has a root? What do you do? Sorry, let me rephrase, let me say that properly. How do you show that this has a root between x equals 1 and x equals 2? Sub in the points, and what should happen? The sign should change. So can we sub in 1 and then we sub in 2? So you have the calculator. Tell me what you get for x is 1 and then what you get for x is 2. So Sarah, why don't you check x is 2, and then Hassan, you can check x is 1. We can make this a family exercise. Yeah. Okay, so for 1 you get positive or negative? positive, and then for 2, you get negative. So then you say, I won't write it down because I've done this a few times now. Then you say, because the because the function changes sign, then there's a root between 1 and 2.
If by any chance we got a mistake in our values, okay, but we wrote the same thing, by any chance, whatever, the root is from this to this.
Oh yeah, you get a mark for it goes 3 marks. 1 mark for correctly getting the x is 1, 1 mark for the x is 2, and then 1 mark for saying because it changes sign, there's a root in between. So you could still get 2 out of 3 if one of your calculations is wrong. So 3 marks for that. Okay, I need you to call the cubic back to me now in a moment. So A part 2 here is the calculation part. So what was my function here? X cubed
minus 3x squared minus 2x plus 5.
Plus 5. And then the derivative is 3x squared
Minus 6x minus
2. So the Newton-Raphson formula is this: xn plus 1 equals xn minus, and then we put the function on the top, and then we put its derivative on the bottom. Alright, what are we told to start with? I'll go back to this in a moment. We're told to start with 2. So, I'll just wait a second for you to catch up. Okay, so what we do first is we put in 2. So you'd get 2 minus, okay, let me try and do this here. 8 minus 12 minus 4 plus 5 over 12 minus 12 minus 2. So that would be 2 minus minus 16, and 8 is minus 8 plus 5 is 3 over minus 2. Uh-oh, something went wrong here, I think.
It's minus 3.
On the top?
Yeah.
Alright, that's better. So that will equal a half then. And I have to do it one more time, and then I get my marks. x2 equals a half minus 1 over 8 minus 3 over 4 minus 1 plus 5 over 3 over 4 minus 3 minus 2. So whatever that equals to, and then we get our answer. So tell me what that is, please.
22 over 17.
22 over 17, yeah? Okay, that's good. So that's 1.3 or whatever, isn't it? Which is good because remember, we expected the answer to be between 1 and 2. We expected a root between 1 and 2. Yeah.
get 1.2?
I don't know. I don't have a calculator. You tell me.
Sorry, 1.2.
Because in there is 0,
4.
What's 22 over 17? Huh? 1.29. Okay, close enough. All right, next one now. So that was 10 marks. So then for the remaining 5 marks, it's a volume one again for tan x. Between x is between pi over 4 what? Finite region bounded between the curve tan x, the line x equals pi over 4 and the x-axis. Dude wrote it wrong. I think he meant to say the y-axis or something, because for the volume you rotate it between 2 points. So clearly one of the points is pi over 4, and I suspect he meant to say the origin or the y-axis is the other point, and then you rotate it around this. Because you know for the limits you use the start and the end. So I'm going to go with 0 and pi over 4. Does anyone have the marking scheme in front of them?
Yeah, 0.
0 and pi over 4. Okay. So basically the question is this. Integrate from 0 to pi over 4 tan squared x dx. Oh yeah, and the pi here too, for volume.
How did you know that from the question after that from limit 0?
I didn't, because I think he mistyped. I think he really meant to say it's rotated between the line x equals pi over 4 and the y-axis. But he said x-axis, which is wrong. So I didn't know from the question. This is the problem. I was trying to figure out what he meant to say because he made a mistake. If this was an exam situation, you know, and somebody misunderstood what he said or she said because they weren't clear, I wouldn't take marks off, because if there's a mistake in the question, it's not your fault. Okay? So for example, if somebody did a different limit, I think it might be okay. But I feel like I should use 0 because most of the time it is usually 0 to something or a small number to something else. So I shouldn't be using a bigger number than pi over 4. After all, even if you got the limits wrong and you had no idea what limits to use, that would only be 1 out of the 5 marks. You'd still get 4 out of 5 anyways. Okay, so tan squared, what can I do here?
Secant.
Yeah, I could do secant squared, but I don't know if there's any formula in the formula book for tan squared. I don't think so. I think we might have to do some trigonometry rule here. Yeah, I think maybe we should change tan into sine over cos, because we're usually working with sine over cos with these anyways, right? Like that's normally the situation. So let's see what happens if I change it to sine over cos. Yes, what did happen to it? It should still be pi over 4. I have a couple of ideas here, but let me see what you think. What should we do next to go forward here?
Change one of them into 1.
Yeah, maybe we could change one of them into 1 minus sine squared or cos squared. But I think that actually makes it more complicated function. What about substitution technique? Could we try that? What could we try here? Yeah, maybe we should try u equal to cos. Let's see what happens, okay? Let u equal cos x. So du dx equals minus sine x. So dx equals du over minus sine x. So this now becomes pi pi, 0 to pi over 4, sine squared x over cos squared x, I'll change it in a moment, times du over minus sine x. Now that's nice here because the sine cancels the square and I can take the minus out in the front. So now I'm left with sine over cos squared. But what does u equal? Cos squared. So I could change this into sine over u squared. But then I have to change the sign. But maybe that won't be too bad. So this will be sine x over u squared du. But now I'm going to have to change the sine x. So what would sine x become in terms of u? Well, this is the problem. What does u equal? Equals cos x. So maybe I shouldn't change the sine x.
Why did you put squared?
Because it's cos squared. And u is cos x. Yeah? So anyways, maybe I shouldn't change the cos. Maybe I should change the sine. So let's try a different way. Minus pi. Oops, sorry. Minus pi. On the top.
Why is it minus?
Well, I'm still keeping this piece the same. And I'm still cancelling here. What I'm going to do now is change cos squared into, sorry, 1 minus sine squared. And here is sine x. D x. Alright, so my instinct is telling me this is not the way to be going because it's not simplifying. So we're going to scrap this and try a different method. Alright, so what are other options? Any other options? Are we all out of options? Well, we can also think of tan squared as tan. No, you don't have to rub it out. It's still a valuable lesson that you learned. What else could we do? Well, we could change tan x into tan x. No, I think secant will be my very last option. Okay, we can change tan squared into tan x multiply tan x, and then we could use what? Integration by parts. Yes, you know what I'm saying? But yeah, I feel like this will not work. So here is my last option, my very last option. I got 3 options. Substitution, not so good. You're telling me integration by parts? Not so good. So our final option, what could it be? No. Huh? I could use compound angles, or actually, so then there's 4 options. Compound angles, or maybe I could use proper and improper partial fractions here. Because remember, you can change the cos squared into 1 minus sine squared. So let me just do the 2 options here. Whoops. Option 1, option 2. Well, let me make some space here. Come on. There you go. If I was to change this to improper partial fractions, I would get this. Pi over 4, 0, pi over 4, sine squared x over 1 minus sine squared x dx. And this looks like x squared, I mean it's not x squared of course, but it looks like x squared over 1 minus x squared, doesn't it? Yeah? So is that proper or improper? It's like a quadratic over A quadratic. So do we call that proper or improper? Improper, yeah. So what do we have to do for improper? Yeah. Yeah. Doesn't sound good, does it? But I know that I can write this as pi 0 pi over 4 sine squared x over 1 minus sine x times 1 plus sine x. Because I factorized this quadratic. Remember, 1 minus x squared, it's like a quadratic, 1 minus x, 1 plus x. Okay. Let's use my best partial fraction power here. 0 pi over 4. Ah, too small. I'm curious if I can try and guess the A and the B without having to go through the trouble of long division. Don't write this part down. This part I'm writing right now. Plus sine x plus sine squared x minus many issues, I know. Right, if you do improper partial fractions, so you do the long division and the whole process, I feel like you should end up with this answer at the end. And we can check if it's right. Because if I multiply the denominators, I get this piece here, don't I? Yes? And then if I do the cross multiplying, I'll get a half sine x plus a half sine squared x minus a half sine x plus a half sine squared x. So in total I get sine squared x in the numerator. So all you need to do is the improper partial fractions in your head. Pieces of cake. But that feels too difficult. But at least now I could get the answer, because then in each case I could continue then. But I don't even feel like this is the best way to do it. I think we should try and go with compound angles. Although it's a little bit strange here because our compound angles have always been sine squared or cos squared problems, you know. We haven't really done a tan x one. But I think this is a good time to learn. Okay, so let's have a look at compound angles. The only rough advice I can give you for this is that it seems to be the case in past exams that if there's a trigonometry function in the integration, probably compound angle is the best way to do it. But if there's no trigonometry function in it, I can't give you any rough rule that would tell you what's the best method to use. Because some methods, after you try them, you might find they're too difficult. Some methods might not work. I can't give you any rule that says, do it this way. All I can say is, if it's trigonometry, it's probably compound angle, but not guaranteed. And if it's not trigonometry, who knows? You have to look at what the problem is. So let's go back now. We need a formula for tan squared x. So tan squared x is tan x, tan x. So what formula has tan x in it? Yeah. Or what formula has tan squared in it even? Do we know any formula with tan squared in it? Well, I think this formula, tan 2x equals 2 tan x over 1 minus tan squared x. We could try this. We'd have to rearrange it though to get the tan squared out. So I'd get 1 minus tan squared x equals 2 tan x over tan 2x. So after a little bit of rearranging, I'd get 1 plus 2 tan x over tan 2x equals tan squared x. What's wrong? It should be... Sorry, I have the sign wrong here, thanks. That should be minus 1 here. So I took... No, don't confuse me. Don't confuse me. I took this to the right and this to the left. Yeah, 1 minus there. Well, that's for tan x, or if you want, our question has tan squared in it. Like this. Got that? My teacher senses are telling me this too will also be difficult. Alright, we'll have to check the marking scheme now. So what way did they do it in the marking scheme? And I'd be so angry if it turns out to be sec squared.
Well, it is.
No, it can't be.
It is. Use it.
I'm not a happy man. Alright. Apparently you have to use sec squared. Isn't that right, Hint? Yeah, interesting.
Like there was someone who's trying to tell you
Yes.
from the beginning of the class.
It's a pity that most of the things you say in class I don't pay attention to. So when you actually do have something useful to say, it's a shame. Alright. Tan squared x dx is equal to... Now, does anyone have the formula book? You can see there's trigonometry formulas in the formula book. But there's one formula in the trigonometry formula book that says tan squared is 1 minus sec squared. Now the proof of that is not so difficult, because you can say sine squared plus cos squared, what does that equal? 1. Now what's sec? What's sec? It's 1 over cos, isn't it? So if I divide all of these by cos squared, what's sine over cos? Tan squared plus 1 equals sec squared. So therefore tan squared, sorry I think I wrote it backwards, is sec squared minus 1. But is there a formula in the formula book for integrating sec squared? I think it is tan x. Is it? Because, yeah, what's the derivative from semester 1? What's the derivative of tan x?
1/3.
1 over cos squared. And what's 1 over cos squared? Sec squared. So the derivative of tan x is sec squared. So therefore the antiderivative of sec squared should be tan x. So this is tan x minus x. And then we have our limits 0, pi over 4, and then our pi as well. You see, for 5 marks, it shouldn't have been a big deal to do. Oh yeah, you just put the numbers in and it's finished now. Yeah, but you see, I'm making it sound like, oh yeah, just do this, that's all. Yeah. It took us quite some time to figure this out. You do not tell me you figured this out by yourself. You were looking at the markings.
Okay, I was helping you. I was giving you the dark, like the shortcut.
This is, it felt wrong. Like, why should you be helping me? It didn't feel right.
You were so miserable. So I said, why not help the guy?
Thank you. It was sympathy help, was it?
See, now
Yes.
it made your life easier.
Yes, you do usually make my life easier. Yes.
When you put in the calculator, use your radians.
Yes, use radians and put in the calculator and you get the answer. So this just further makes my point. Factors I like in the exam. Integration, no liking. Okay. Yeah. Tastes bad. Don't like it. I don't think I'll do the last one because if it's exactly the same, what's the point? So let's have a look. I know, but even next class I don't think I'll do it. Shh. Does that look familiar? Yeah, it's 100% the same. Mean, standard deviation, cumulative frequency, and then to finish, the median again. Now that doesn't mean it'll be like that for your exam, because remember I said there's 2 possibilities here. Cumulative frequency, and then what's the other one? Histogram. It's just that this one is more common. Don't know why. I have made for you a practice maths exam. So, yeah, I don't know. It's just when students ask me for something and you look at me with your big sad eyes and I think, oh, how could I say no? So yeah, I made you a maths exam.
Those big fat eyes that you look at. She won't be in the exam, believe me.
Are you still confident about this?
Yeah, because.
Oh yeah.
Before she
It'd
comes.
be difficult when, you're dead doing an exam, yes. So I have the maths exam made, a practice one. So we can do it in any of the double classes. So, how about we do it on Monday's class then?
This Monday?
No, certainly not.
Certainly not.
Yeah.
Well, when's the next double class after the Monday?
It's next Monday. All that.
Next Monday.
Yeah.
Wait, it's Monday? Monday's our own double class.
Yeah.
Yeah, so,
Well, we have.
wait.
On Wednesday. On Wednesday.
But it's not back to back. I want to make it like an exam environment.
Everyone's free, the externals.
But the big room won't be free, Listen, this isn't an exam.
Next
I'm going.
Monday.
Next
week. Yeah. Why not?
This Monday?
Faisal!
No.
Wait!
You don't need to study.
Hey, Faisal! Teacher talking. Right, okay, look. I'm not going to take this example and correct it. What I'm going to do is give you the example, you can sit down and do it, and then I can give you the marking scheme or go through it in class or both or whatever you want to do, okay? But I'm going to give you an exam. I'm going to give you an exam that you have not seen, okay? It's complete. All the questions are new questions. What I mean is the practice exam, I didn't take any of the past questions. They're made up questions, So it'll be a good test for yourself to see how well you would do if that was the real exam.
Give us the notes on which day? Monday. This Monday?
Monday.
Yes.
I'm feeling like for Monday, this is good.
This Monday.
Yeah, because it means
Practice.
It's yes.
That's
Thank you, Curdy. No, leave it alone. Leave it alone.
I'm telling them to memorize the date, this Monday or next
This Monday, okay? Because that way, if you do the practice exam this Monday, when everybody's working on the exam, I can be correcting your maths assignments. So that way you can get your maths assignment a little bit sooner as well. You can get the grade for this, okay? Because I have really no time to sit down and correct it during the week. So if you're all working on a maths exam during the class, I can be correcting your assignment. And I can, if I get them all finished, I don't know if I will, I can give you your assignment grade after the class. I might not get them all finished though, okay? And we'll do the test on Monday. I'll print out the exam, I will print out the formula book. Just bring some paper and a calculator, okay? And we'll try to do it like an exam, so you can't talk to anybody. And you can see yourself how screwed you are. I mean, how well you're doing. Yes? Alright, okay. Right, see you soon.